Hi, this is Charles C. McGowan with the SolREI Company. This is another presentation in the series of informal discussions that we'll be having. This is In Unification's Wake, Part 1, and it is a series of charts that discuss kind of the typical questions that come up when people first encounter the fact that unification has been accomplished, and they're like, well, what about this and what about that, and how does this do and how does that happen, and etc. And so this is just an introductory set of charts to begin those kinds of discussions. We are putting the presentation online in the presentation folder under the SolREI folder in the user library on our website. That's www.solrei.co. You will need to register to see and download the presentation if you want to do that. Registration doesn't cost anything, it's free, and the best way to view the presentation charts is to log into the website and then bring the PDF file up, and that way any hyperlinks that are in it will resolve back to their respective pages on the website. The charts that you're going to see that we're going to go through, and I think there's a little over 20 of them, they are not in any particular order, so please do not ascribe any kind of priority or importance to whether the chart shows up earlier in the presentation or later in the presentation. That has no bearing on anything. The abstract of this presentation is that there are a number of concepts which, when mode shifted, are either destroyed outright or are simply evaporate in the wake of accomplishing unification. And in today, that specifically means in the context of M5 most often. But I want to mention here that don't ascribe any kind of finality to the emergence model. It just simply happens to be the first model that closes to unification, and so we use it as an example here. Somebody at a later date, once people really come to understand what the framework is all about and how the epistemology works and all of that, then somebody may come up with a better model than the emergence model. We simply offer it as part of the elegant reasonism framework and epistemology, because that framework requires at least one of the models used close to unification. It meets what we call the realm of C's. And because the emergence model does, it's used here. And because it happens to be at this point in time the only one that we have, it's used as the example here. But that may not always be the case, and so we encourage you to just take that into account in the situational awareness point of view. So with that, let's get into the presentation. The first chart is on mathematics, and the mathematical domain of discourse really is parsed along relative and respective areas of the tool that we call translation matrices that we talked about in the earlier video, the introduction video. So if you haven't seen that, I would encourage you to go watch that. It is 2 hours, or about 2 hours, and just get kind of familiar with what that is and how that works. Context. When we think about mathematics, we are so used to thinking about it in the context of what it is we've come to know as the predominant thinking in the physical sciences. We call that M1 in elegant reasonism, and each encapsulated interpretive model, M1, M2, M3, whatever, establishes its own context. So when you look at, in the earlier video, we used as an example y equals x z squared or something, and compared that to E equals mc squared, and pointed out that the distinction between the two, the math operations are the same, but the definitions of what E is and what M is and what C squared is and how those things interact and what the relationships are requires an understanding of the definitions of those variables. And so the point there is that each encapsulated interpretive model establishes its own context. And it is that context that, is a function of that effort. And when we take a look at that encapsulation in the framework of the translation matrices, the patterns of those relationships vary model to model to model for the same paradigm of interest. And so the mathematical operations don't change, but where they are applied in the translation matrices may change the definitions being used that would be quantified and codified in that ISO 9001 unification tool, for example. And so the mechanical aspects of mathematics don't change, but the variables and the meanings behind those variables may very well change. And the constant C, for example, in M1 is ascribed to the speed of light, and in M5 it's ascribed to severance. And so there's a difference in how things are applied, what they mean, what the definitions are, those kinds of things. But they still result in probably a number that's pretty close to the same thing. And in the case of the constant C, it would still produce the same number relative to the speed of light, but its meaning and how it manifests that is radically different between M1 and M5. So you just have to be situationally aware of those kinds of things and take those into account in your thinking. But as a general rule of thumb, the mathematics doesn't really change. The existing empirical evidence. People don't directly interact with reality. Human physiology is such that we create abstractions so that we can relate to reality. You can apply any number of labels to any given object. Each of those labels has a different connotation in terms of depth of detail or some other aspect of the symbology that's applied. And what we uncovered was the body of work of Suzanne K. Langer, who was an American philosopher. Her book, The Philosophy in a New Key, from 1948, I believe, just makes the point that believing any given abstraction is actual reality constitutes a fatal flaw in epistemology. And we have named those kinds of errors Langer epistemology errors. And that's how we get into logic traps and concept compression kinds of issues. And that's, so for example, BX442 is a galaxy that is so far distant, and it's a grand design spiral galaxy, but it is so far distant that there is not time for it to have formed since the beginning of the Big Bang under M1 rules and M1 thinking. And so that constitutes a logic artifact. So that's an example of where existing empirical evidence is not congruent with the current thinking. And it's a long story, and we'll get to it later, but how M5 reconciles that is actually quite fascinating. But the point is that empiricism is intrinsically and inherently tied to human physiology. As we encapsulate the interpretive models, we establish a fundamental foundational context for each model. And it is in that context which empirical evidence has been tied. People want to know how we can possibly dismiss the body of evidence that we have today and all of the things that civilization has been built on. And the answer is it's not wrong, it's simply logically correct. And it's not until you understand the implications of what that means do we begin to be actually liberated in order to think in new ways. So logically correct experiments conducted in logically correct manners, immersed in a logically correct encapsulated interpretive model, will very likely produce logically correct results, and that has absolutely nothing necessarily to do with the actual reality underpinning those results other than the logical correctness with which they were derived. And that does not preclude there being an alternative to that same experiment. It can also be simultaneously logically correct with what was done. It's just that it's a different model. And the point there is that when you mode shift something between an experiment between M1 and M5, what you're going to find is that they are both simultaneously true because they are both logically correct. And so that's the point of empirical evidence, and it's also an example of how elegant reasonism is a superset epistemology, and it integrates empiricism inside of it, but it weights things statistically, and it asks the question, does the way you're thinking close to unification? And the answer to that question is a yes or a no. There is no other alternative. And if the answer is no, then you need to really think through how you're thinking, and go back through the framework and the epistemology according to elegant reasonism rules. So when we mode shift existing knowledge, the warning there is that the fundamental foundational context is highly systemic, and it changes driving relationship pattern distinctions within and between and across various encapsulated interpretive models for any given paradigm of interest. And so you need to be situationally aware that the known knowns, the known unknowns, and the unknown unknowns may have different constituents within those sets, those mathematical sets, if you considered them a mathematical set. And also the standard answers to what, when, where, why, and how may mode shift between those models, model to model. And I'll give you an example, is Newton's laws. So when you look at Newton's laws under M1, there's a whole host of questions that one has to answer and has to think about in terms of, for example, space-time being real, and if it's considered to be real, then does it have stress? Does it have tension? Why does it not affect objects moving through it? If the object has mass and it's warping space-time, why is there no friction? Etc. And so photons can travel across the known universe to go from BX442, for example, to the imaging systems in the Hubble Space Telescope with little or no effort. And so and photons, oh, by the way, do have mass. It's just very, very small. And so we, for practical reasons, have been saying that it doesn't have mass, but it does. And so when you go over to look at M5, and you can log on to the website and see that description there that we discussed in the earlier video, you intrinsically see why Newton's laws are true. It's intrinsic. It's patently obvious why they're true. But what you also realize holistically when you come back, when you step back from having mode shifted that, you see that the M1 description and the stuff that you would typically see in a textbook is a description of what happens, not why it happens. And then you look over at M5 and you suddenly realize that that description is why it's happening. And so there is a relationship between investigations when you're doing a systems review, that mode shifting existing knowledge can be done in a very, very productive manner. And you just have to be situationally aware of the contextual distinctions model to model, and you need to expect the unexpected, because it's really an awesome experience to go through these things. And this happens across all domains of discourse. It doesn't matter where they are. It's an astounding thing to go through, and I actually look forward to all the smiles that I know I'm going to see in the months and years to come. Mode shifting entanglement. This is interesting from a lot of different points of views. So a question is, what do rainbows and something pilots often see when they're flying? And there's some example videos on our website in the SolREI Studios, actually in the SolREI Studios channel on YouTube, called Glories. And it is a rainbow with the aircraft's shadow in the center of the rainbow, and it's a full circle rainbow. It's 360 degrees. So the question is, what do rainbows, glories, and the two slit experiments in physics and the wave-particle duality all have in common? And the answer to that question is entanglement of architectural mass limited by severance. So architectures of mass are complex, composite, and dynamic. They are not static. They're moving. They're not necessarily isotropic. I tend to think of photons, for example, like little dandelions. They have little wispy features to them, but there's a lot we don't yet know about these architectures, and we'll get into that in a minute. But architectures can be kinetic and or have kinetic constituents. So for example, if BX442 is emitting a photon that's going to ultimately wind up on the imaging sensors of the Hubble Space Telescope, then it will trace out a straight line path between those 2 points that astrophysicists will call a geodesic. It's not literally a straight line, but it is a straight line relative to things like the Lorentz factors and other things, and gravity, and gravity wells will affect the frequency arm of a photon, for example. But anyway, I digress. The constituents within an architecture can dampen and constrain otherwise dynamic constructs. And in that case, think quarks inside of a proton or a neutron. There's also a whole series of things in the emergence model of particle physics, which is an extrapolated version of the standard model. It's not extrapolated, it's a mode shifted version of the standard model. But quarks don't stand alone, and they'll disintegrate if they're not constrained in a larger construct, and that's kind of the point there. Structures can change severance values as architecture absorbs or transmits internal force and stress. The example here is something that a lot of the engineering schools around the country will do, around the world actually, will do. They'll ask students to build boats out of concrete, or they'll say build a bridge out of soda straws or popsicle sticks or toothpicks. Something that's individually weak, but when it's put into an innovative structure, can withstand tremendous force. And that's kind of the point there, is that the complexities of the architectures of mass can change severance values, and that's something that we have to investigate going forward. And that's part of why the formal studies and systems reviews are going to be very vital going forward. The multiverse. I wish I had better news. The multiverse is a concept that there are an infinite multitude of space-time bubbles, each of which is a universe in and unto itself. The concept requires M1, M2, or M3 to be real descriptions rather than the logical constructs that they are. And the point there is that it requires the commission of a Langer epistemology error to believe that the multiverse is real. Multiverse is not real. The multiverse is it's a logical construct that is a function of that Langer epistemology error. M5 describes space as dimensionless. The multiverse requires a core construct to be dimensionally defined. Another point would be that nothing real can transit the space-time mass interface. M5 establishes any MBP or set of them as the geometric basis point in any given event frame. And also that M5 develops a concept that dimensions are a function of the intrinsic nature of most basic particles and not space. Space in M5 is defined as dimensionless nothing, and therefore cannot support any kind of concept like a multiverse. So the multiverse in M5 does not exist. There's no basis for it. And we'll talk about other aspects of these same factors and how they relate to other things on some charts that follow here. One of which is parallel universes. And this is an important chart for actually for resource reasons, but parallel universes are the concept that there are an infinite number of universes parallel to the concurrent timeline. And so if you were forced with a decision and to go right or left, for example, in the realm of parallel universes, you would actually make both decisions, and that would constitute a different timeline. And there's an infinite number of these, but again, you run into the same issues. It requires real descriptions rather than logical constructs that they are. They all use the space-time construct, and it requires commission of a Langer epistemology error. It requires you to believe that those constructs are real, but they're abstractions. They're not reality. M5 defines space as dimensionless, and the dimensions are functions of MBP, not space. We just talked about that. And we talked about space-time mass interface. The point here is that, for example, if you're not using elegant reasonism and you believe that M1 is the only way to think and that you're actually describing actual reality and that space-time is real, etc., setting aside for a minute that you've just committed a whole host of Langer epistemology errors, they're actually doing experiments in Switzerland at CERN. They think they are poking at parallel universes. So they inject energy into an experiment and they get something back out. They don't understand that what they are actually doing is injecting energy into a soup, and that the soup is assembling consistent with the fundamental entanglement function limited by severance, and it may produce particles or virtual particles coming out, and they think that those things are from a parallel universe. They're not. They're simply configurations of MBPs that would not have occurred otherwise. They're not from a parallel universe. They're from our universe. They are simply a different way to think. But once you mode shift those experiments through elegant reasonism framework and the epistemology, you suddenly have a different set of insights on the results that you're getting. And they are spending billions of dollars on these experiments. And they're not taking into account the broader thinking that's required in elegant reasonism to understand the results that they are getting. They're simply making assertions based on the fact that they've committed Langer epistemology errors, and it's a bad news bears kind of thing all the way around. But the good news is we now understand the framework and the epistemology in the context of the unified universe, and we can hopefully correct these things in the going forward kind of effort. Time travel. Science fiction people all over the world are going to hate me for this. Time travel is a novel concept that one can travel into the past or the distant future. It's a standard fare in science fiction literature and movies and things, and it's been one of my favorite things when I was a kid reading different novels and things. I was just the paradoxes and all that. Harlan Ellison is an author that comes to mind, as and Paul Anderson and others. M5 defines time as an action displacement index, and the implication there is the unsaid word is that action displacement index between relative and relevant architectures of mass and complex composite architectures. Action, in the context of the action principle of mathematics, action is always positive. Consequently, the arrow of time is always forward. Always forward. Even if you back up, it's still forward action that's being performed. M5 eliminates the dimensional nature of time as envisioned in M1, M2, and M3. The resulting index of relative and relative action creates the illusion of time. M5 establishes that the intrinsic nature of MBP derives from two processes. A build process called the fundamental entanglement function is limited by the other, a failure process called severance. Severance is responsible for the constancy associated within the concept of time, because everything fails at the same point, because everything is a derivative of most basic particles under M5, means everything essentially fails along the same set of values. Those values may be shifted slightly because of structure and other considerations, but that's fundamentally a function of severance. Severance is responsible for the Lorentz factor measurement changes. So, as the things that the Lorentz factors would calculate as time dilation, or those kind of things are handled by severance. And the other point here is that this is the M5 insight here is that it's consistent with everyday experience. And it's like Stephen Hawking once held a party for future time travelers and nobody showed up. So it's time travel is a logical thing, and it is a derivative of M1, M2, or M3 thinking. The notion that nothing can exceed light speed is one of the original constructs from Albert Einstein's 1905 paper on relativity. And back at the time, there was a real famous experiment that actually happened a few years before Einstein wrote his paper, his first paper. and it was the Michelson-Morley experiment. They built a device called an interferometer that used converging beams of light to put a pattern up. They were trying to detect what they thought was, what everybody was calling at the time, the luminiferous ether. It was the medium of space, and their experiment failed, and everybody thought it was going to succeed, and it did not succeed. And I think my personal opinion is that that's probably what drove Einstein to start thinking about different ways of thinking about what's going on in the medium and relativity and whatnot. But when he came up with relativity, one of his rules was that nothing can go faster than the speed of light, and it was convenient for him to think of that as a part of the dimension, and that's how we get to c squared, and that's how we dismantle c as a unit of 1 back to the other 3 dimensions, and also come up with the fourth time as the 4th dimension. So there's a lot of synergy in that logical kind of thinking, in that framework, and it was brilliant. It was a brilliant way to think about all those things. What M5 does, though, is explains when we mode shift those experiments, and we mode shift the light patterns of the converging light beams, we find that it's a function of entanglement and of the complex architectures of the photons, and we find that the metaphor that I've used in the past with some degree of success is imagine a weapon, a gun of some sort, and you have 1,000 rounds of ammunition. The bullets that come out of that gun are all going to go essentially the same speed, but they're going that speed because of the system that emitted the bullet. That is the gun, the ammunition, the cartridge, the powder, the primer, whether the barrels are rifled or not, etc. Da 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 da. And so it is the system that produces the bullet at that constant speed, not some external limitation on the bullet, from the moon or something, or from the earth or the air or whatever. And so when we look at that, we find that the severance, in terms of the architectures of mass, because it's an intrinsic feature of the nature of MBPs, C gets mode shifted to severance in M5, and when you step back and you look at other equations, and you realize that C is severance, not the speed of light, those other equations suddenly make a great deal more sense than they otherwise would have. And so this is a very insightful, kind of awe-inspiring, jaw-dropping moment when you encounter those and you start putting them back into this context. Interferometers, like the device that was used by Michelson and Morley, measure local event frames. Cosmological frames and spectral analysis actually support vindications of Edwin Hubble's body of work as superluminal. And so things do all day long go faster than the speed of light, and the galaxies are receding from one another. We'll get into that in just a minute. We can mode shift the body of these different factors between M1 and M5, going back and forth, and you'll see how that in the coming months and years and subsequent videos that we do, how that all comes back together. But it can be done. It has been done. And causality is a function of action, not dimension. And so there's no causality violations here, just because we can in fact go faster than the speed of light. So the Big Bang is characterized as the initial event resulting in everything we perceive as, quote unquote, the universe. The first thing we need to realize is that, again, M5 defines space as dimensionless nothing, which then requires all the attention to be mode shifted to the architectures of mass, which are derivatives of the intrinsic nature of most basic particles whose configurations produce all real objects, and that includes black holes. Severance results in a concept called the frangibility of mass. Frangibility just means that it can break up into an array of smaller constituents. But when you do that, you also not just divide up the particles or the architecture, you divide up other factors like momentum and inertia. Severance results in the frangibility of such defined mass in event frames whose values exceed those limits, including black holes, because everything real is some in the emergence model is some configuration of MBPs. That opens up the an option to redefine how the Big Bang happened. It's not a quantum mechanical fluctuation in a finite region of space, for example, as M1 might describe it, but M5 envisions the event frame of colliding black holes whose mass is equivalent to the measured mass and characterized by energies exceeding severance for all objects in that frame. So in this case of the Big Bang, those total masses would be the total mass of what we were measuring now inside of our particle horizon with the WMAP effort. And because the WMAP data supports statistical circles, implies that there was more than two objects in that particular event frame. And there's more I want to say, but I'm going to save it to a later chart when we talk about galaxies going away from each other, because they are. But the implication here is that because of those statistical circles and because of the velocities that would have to be going, these two objects would have to be going when they achieved values exceeding severance for everything in the frame, implies that there is a tremendously huge, much larger than anybody ever fathomed universe that we're all a part of. Okay, our Big Bang was the Big Bang, and this is part of what I was just alluding to. We stereotypically characterize the initial event resulting in everything we perceive as the universe, and that is all that there is. Our universe resulted from this event that we can use the WMAP data to kind of investigate. In that context, though, because of those statistical circles in the WMAP data, and because they imply that there were more than two objects in that frame, means that not only is the universe bigger, but these kinds of collisions are occurring everywhere. They're so far beyond our particle horizon, we have no perception, no ability to perceive that they're going on. So when we look at galactic acceleration, the fact that the galaxies, the supermassive black holes, are in fact racing away from everything else, supports this view of how the Big Bang manifested itself. Once we take the Z factors and we mode shift those, we can get a better view of how big our universe actually is. There's a lot of work we have to go do now, and the other point I guess I would make is that black holes in M5 are essentially graviton stars. So if you look at the normal stellar evolution, we see nuclear fusion going on in the standard set of stars. Then beyond a certain mass, they pull in and they become neutron stars. Beyond neutron stars, the collapse continues, and we've been calling them black holes, but because the gravitational attraction is so large that not even light can get out of it, they are essentially graviton stars. Okay, the inflationary theory. So when we take Edwin Hubble's data that showed things going at superluminal velocities and combine it with Albert Einstein's views from his two papers in 1905 and in 1916, I think, there had to be some way to reconcile that, and Alan Guth and other folks working, I think, primarily at MIT, came up with this. That said that space-time itself was expanding, and that's called the inflationary theory. And under that theory and other theories, the Big Bang created space-time, and it expanded very rapidly in the first 3 minutes, and that expansion continues as the supermassive black holes race off into the void. But again, M5 defines space as dimensionless nothing, therefore it is not created by the Big Bang. M5 holds the Big Bang as a function of the event frame of supermassive black holes whose vectors intersect and whose energies exceeded all severance values for that frame. The statistical circles in the WMAP data suggest more than two objects were in that frame. Severance results in the frangibility of all mass under those conditions exceeding those values in such frames, in such event frames. Such supermassive objects dismantle into the mirth, which are MBPs, which instantly, because it's the intrinsic nature of the MBP that we derive the fundamental entanglement function limited by severance. And they in this event, they instantly begin reassembling consistent with the M5 cogent description that's up on the website, SolREI.co. Just go there and search for M5. You'll find it. The inflationary theory requires a concept called rapid expansion that happened in that first 3 minutes in order to get to the size of the universe that we have today and see through the science of astronomy. Rapid expansion as a concept has a corollary called infinite compression, which cannot be reconciled against black hole growth. What we've noticed, you go pull up any long list of black holes, you'll see that they are different sizes. They grow. They're different sizes. And because they grow means there is no concept in nature of infinite compression. When we kill infinite compression, you kill rapid expansion because it is the corollary of it. And so if there is no rapid expansion, it means that the logical description of the way the Big Bang has traditionally been described is false. And so we know we have to look for a different description. The description that we have here for the Big Bang happens to be consistent with the cogent description for M5, and it fits, and it dovetails seamlessly. And it also eradicates all of the logic traps and the logic artifacts that we would find in M1. And so when we mode shift all those different things, we can come up with a treatise that's consistent and has great affinity with the unified universe. The notion that space-time is real is Langer epistemology error. I don't know a nicer way to say that. Space-time is a logically correct construct in the context established by M1, M2, and M3. So again, when we back up all the way to that mathematics chart, when we set up a logically correct model and we do all these experiments and we come up with logical results, all that means is that that's logically correct. It does not mean that there's not another simultaneously logically correct way to describe those phenomena. And that's what happens when we mode shift those experiments back and forth between M1 and M5. So in this particular case, it turns out that space-time is a logical construct. It is not real. The mathematics depicting the correct resolutions regarding space-time are in fact justifications for the logical correctness of the context that is established by the encapsulated interpretive models employing that construct. That means M1, M2, and M3. And again, logically correct experiments conducted in a logically correct manner, immersed in a logically correct encapsulated interpretive model, establishing a logically correct context, will most likely produce logically correct results. And that has absolutely nothing necessarily to do with reality other than to illustrate that it is capable of supporting that logical view. It does not eliminate any other encapsulated interpretive model's context from also being logically correct. And in the case of M1 and M5, that is the situation that we have. So you can take a series of paradigms of interest, run it through the framework of elegant reasonism and the epistemology that it supports, and you will see that M1 derived results and M5 derived results are simultaneously correct, but M1 will never accomplish unification. M5 closes. M5 does accomplish unification. Does that mean that there won't be an M12 or an M14 or something else? There may be. I hope there is. But the point here is that just because we have math that will dovetail in a particular context does not mean that there won't be math that also dovetails in a slightly different context, but both manifest the same paradigm of interest. So space-time is unfortunately not real, and it is a logical construct of M1, M2, or M3. The Lorentz factors. We talked about those a minute ago. The Lorentz equations have been long historical affinity for and with relativity. And I'll mention too that the user library here has a very extensive biographical folders there for you to use and to reference. And Lorentz is there, and you can see his original works. Some of Einstein's original papers are there. Maxwell and many more people are all there, and for historical research purposes. And when you mode shift these things between M1 and M5, it really is fascinating to see how they manifest simultaneous truths. But again, you have to always ask that philosophical predicate priority consideration question, and it is, does my thinking close to unification? If the answer to that is no, then you need to kind of back up and climb off that precipice and ask, why not? Why doesn't it close? What's the inhibitor? What exactly is the issue? And in the case of C, for example, we've used that example. When we mode shift that, it moves from associating it with the speed of light to associating it with the severance values for the photon, which result in the same speed and same velocity. But in the case of M5, it's a function of the system that produced it. In M1, it is a function of the dimensionality of spacetime. And so there's two different ways it gets manifested. It has different implications to it. When we get into logical views of physical systems and gathering systems engineering requirements and speccing those all out, that's when these things matter. The details matter. Okay, microscopic black holes. This came up when the Large Hadron Collider was in operation in CERN, and they were doing some experiments there, and everybody was saying, oh, well, it's going to produce black holes. They're going to zip off at the speed of light, and they're not going to affect anything, blah, blah, blah. Well, no. They didn't produce any because there's a minimum size. When we start looking at M1 and M2 and we mode shift those experiments over, we find that there's an action per unit area minimum relative to the Schwarzschild radius, suggesting that there is a minimum radius for black holes. And the smallest black hole on record at the time that we looked through everything was about 10 solar masses, and it yielded a radius of about 30 kilometers. And my personal belief is that that's going to be about the smallest black holes that we're probably ever going to find. We might find some slightly smaller than that, but that's about it. And so the notion that microscopic black holes can exist is that notion goes away because of the issues between M1 and M5, for example. And when you mode shift those things back and forth to each other, you find that they can't collapse. They don't have the action per unit area availability to cause the gravitons to pull everything in to generate a graviton star. That requires about 10 solar masses with a radius of about 30 kilometers in order to accomplish. So microscopic black holes are not considered real by M5. The age of the universe. This is a very, very interesting thing. So when we reconcile the Hubble data with the WMAP data, and we start normalizing Z factors, which traditionally in predominant thinking were ascribed to expansion of space-time, and we mode shift all of those concepts between M1 and M5, what we find is that Edwin Hubble is vindicated. Those things are much further away than we thought they were. The universe becomes vastly larger than we thought it was, and it also grows in age. The only word I can ascribe to it is ancient. And we collectively need to do a systems review on all of that and really go back through the WMAP data, and something that we didn't have the resources and don't have the resources to do. But our expectation is that we will come on some number for an age of the universe that exceeds 70 billion years. It may be, numbers that I've came up with just from my meager little effort. Some of them were around 120 billion, and I've seen some as low as 70, but it depends on the Z factors and the particular sets of stuff. But we need a comprehensive systems review on all the Z factor, as they've been applied historically, and galactic acceleration, etc. And when we do that, then we can come up on a cleaner estimated or anticipated age of the universe when we mode shift that back and forth. But when we do mode shift that, what we have found is that galaxies like BX442 are instantly vindicated. Instantly. The logic artifacts associated with that evaporate. They go away. They're non-existent. Because suddenly now BX442 exists in a place where there was time for it to evolve into a grand design spiral galaxy. And we expect that as the James Webb Space Telescope comes online, and it can perform similar ultra deep field views, that we're going to find things even much further out than BX442 is our expectation. And that when we normalize and we mode shift all these different data points and perceptions and concepts and constructs, those things will line up and will be vindicated in the unified universe. The universe is unified whether we think about it that way or not. It doesn't care what we think. So, it's important to remember that. Teleportation. Teleportation is a concept in M1 or M2 thinking, resulting in a conversion of a real object to energy in one place and to a reconstitution of that same real object in a different location. The emergence model recognizes that information is a function of complex composite architectures of mass, period. If you destroy the architecture, you destroy the information associated with it. Therefore, teleportation is not considered viable by M5 in any manner. So, when things get eviscerated at the event horizon of a black hole, they're gone. It may get reconstituted into a similar object just because of the evolution, the intrinsic and inherent evolutionary path of the fundamental entanglement function limited by severance, and we perceive those as following knot theory. They're going to produce those same sorts of configurations, and those same sorts across the permutations of things will come up with the things that we see and experience in reality every day. Faster than light travel. When we dismantle the limitations imposed by relativity under M1 or M2 or M3, which we did a little while ago when we talked about the systems producing a photon versus a limitation of the dimensional spacetime. Dismantle that means that, and Hubble gets vindicated in that, and his data does show superluminal things, means all the things can go that fast. But before all the science fiction people get real excited and suddenly we can go that fast, there's a whole nother series of things that we have to start thinking about. The things like warp drive and Alcubierre drives and those kinds of things, they go away because there's nothing to warp. There's no dimensionality associated with space, so hyperspace goes away. But we then discover things about managed severance drives, which may emerge and can hold promise. But the problematic side of that is that supernovas eject massive objects into interstellar space. Even a small object, as small as a particle, becomes very problematic if that thing hits you or you hit it. The chances for deflector technology at this point do not seem very viable. This means that generational transport would likely be preferred. Everything in space is moving, and we have to go back and we have to mode shift all the Lorentz factors and etc. And this last sentence on this bullet here, it says, if you miss your target destination, you may be traveling along that vector for a very, very long time. And the point there is that if you do get up to high velocity speeds, leaving a system for a target destination, if you miss that, there's nothing for you to grab onto to slow or change or alter your vector. And so you're just stuck. And you're stuck going in a spacecraft going really fast along some vector that may go into the void of interstellar space. In inter-universal space, if you want to consider our universe versus some other set of black holes that collided somewhere else. Now, having looked at all this, and we went back and looked at the Kepler data from the Kepler satellite that was looking for exoplanets, and ironically, the Kepler data has another list implying the existence of Dyson spheres. And the fact that there are these locations that looks like that's what they may be doing, instantly vindicates the emergence model. It vindicates elegant reasonism, and it also reconciles the Drake equation with the Fermi paradox, which we thought was rather amazing. So it simultaneously explains how life emerges, and life is probably everywhere. And then the Fermi paradox is okay, if it exists everywhere, how come we don't know about it? And the answer is this set of circumstances and mode shifting between M1 and M5, and presuming that there's not an M12 or some other model that's better than M5. And so, they may know something that we don't know, but the point that these things that look like Dyson spheres are coming out of the Kepler data was rather exciting for us, and we feel like it kind of vindicates what we've been working on for over 16 years at this point. Okay, does M5 and M6 answer everything? Holistically, the emergence model is comprised of both M5 and M6. It takes a holistic view of both of those to constitute what we call the emergence model. It is the emergence model, required by elegant reasonism and not just M5. There remains a great deal of work to do, and while that is true, there is much they have to teach us even in their nascent state today. So we can mode shift existing knowledge. For example, we know almost nothing about the complex composite architectures of mass in the context of knot theory relative to M5. And one of the proposals that we constantly make and request, and we need help, we think that there needs to be a computer system that's probably an order of magnitude larger than Summit, which is the largest, most powerful computer on Earth at the moment. But the computer that we would envision here needs to go into the architectures of mass. We need to know how these architectures manifest physical properties, and we need to go through all of the string theory and other things, and really investigate the intrinsic nature of most basic particles. There's a lot of research here to do. We need to really mode shift all the details between the standard model and the emergence model of particles, and that includes the virtual particles. And there's a lot of insights and R&D that we can do. RF antennas is one area that we think might hold some promise, but there's just a lot of things. So M5 does not answer everything, and it also is that we don't know where MBPs come from, for example. We don't know, inevitably that comes to an argument between something and nothing, but it's a chicken and egg thing, right? So it's the same philosophical genesis that we have for M5 that existed for, everybody in M1 thinking is like, what banged before the Big Bang? I mean, where did it come from and why did it bang? Over in M5, we can answer the why it banged part, but we still don't know where the MBPs came from. So we still have questions to ask and look for answers. Don't know where that's all going, but we do at least know now that one of the things that will help us do that is a very large computing system, probably the largest computing opportunity humanity may ever have, and we need to pursue that. So why do we know that elegant reasonism works? I mean, why are we so sure that this is a better way to think than the way everybody else has been thinking for the past 100 years or so. Part of the answer is that it closes to unification. Part of the answer is that it recognizes the implications of commission of Langer epistemology errors, which has not heretofore been in anybody's palette of toolbox things, instruments. But the elegant reasonism seeks truth as a function of the unified universe. Truths meeting those requirements are universal in nature, and to the extent that models employed meet those same requirements, that will be an enduring objective. And it doesn't matter whether that truth is determined by M5, M6, or some other model, as long as it meets what we call the realm of the C's. There are words like cogent and coherent and closure, and it closes to unification. And it does these things as a predicate priority consideration and then enters science. If you're locked in the logic trap that is M1 thinking, and you think that you're on a mighty precipice and it's very powerful, and look at what we've done, and it creates all these wonderful things that we've done in the GPS satellites and yada yada, whatever, that's all well and good, but if the total sum of what you're doing cannot be shown to close to unification, then it's not the right model. It's the same point that Richard Feynman would make about experiments and science. He said, it doesn't matter how you describe it. If it doesn't match with experiments, it's wrong. Well, if it doesn't close to unification, your experiments aren't reflecting actual real reality. It's not that they're wrong, it's just that they're only logically correct. And so what we need to move to from Feynman's original dissertation is that same experimentation has to be able to be mode shifted into an encapsulated interpretive model that closes to unification and aligns with the unified universe. So it's necessary but insufficient to meet the constraints of context that does not close. So we need to make sure that our experiments can be mode shifted along those lines. And that's the end of In the Unification's Wake, Part 1. We will try and come up with some other ones later, or maybe even enhance what I said to this set of charts at a later time. But want to thank you for your time and attention, and we'll see you on the next video. Thank you.